Oh, just kidding. Let me put that back. 4-1. Let's see. Let's go back. Let's look at it. What did you do, Hannah? Sounds good. And that gave you negative 2x plus 4y equals negative 4. So you add those up, you get 7y equals 7. So how'd you get something other than 1 for y? Oh, well, anyway. Sounds like you did the work right. So 4-1 is correct. Today we're going to be doing the same thing except with 3 variables. Hence the second part of this problem, which I left off. Now, today, 3 variables, but not all 3 equations might have all 3 variables in them. So if you get something like this today, let me just say, start out just by solving for 2 variables. And if they give you something like this, where 2 of them just have 2 variables, solve those just like yesterday. Plug in for x and y into your third equation. So in this case, it would be 1 minus 4z equals negative 7. And you can solve for z. It's a 7.2. And I'll warn you now, I know we jumped way ahead to chapter 7. We're going to be jumping back and forth between chapter 7 and 8 for the next few weeks. And we're going to combine those 2 chapters into one test. So, but there's a lot of activities we can do in this chapter, so should keep it pretty loose. And it should have better flow than the last one. Good. Today we're doing 3 third-ordered systems of equations with 3 variables. And we're going to do the exact same thing that we did yesterday. Exactly. Only difference is you have an extra variable and an extra equation. Our goal, we have a 3 by 3. Our goal, now yesterday, it was to reduce our 2 by 2 into solving for 1 variable. Today, we're going to try to take a 3 by 3 and use different processes to reduce that into a 2 by 2, which we now know how to work. So, using the exact same steps as yesterday, does anybody see just one particular step we could use to get rid of a variable? Kelsey? In the top 2? All right. So she says, let's use the addition method for the top 2. Let's add those 2 up. 2x minus y equals 5. When you add the top 2 together, that's what you get. So, we've gotten rid of one z. Now we need to get rid of another z so that we'll have two variable equations. So what other combination of equations here can we use to get rid of a different z? Add it to the bottom one? I like it. Multiply the top one by 2, which I'll rewrite right here. 2x plus 2y plus 2z equals 8. Add it to the bottom one. It gives you 4x plus y equals 7. And just like that, using the addition method, you've combined some of these systems of equations and you've reduced it into a 2 by 2 system, which is just what we did yesterday. From here, it's just exactly what we did yesterday.
It's just the process of eliminating variables?
Yep. In fact, do we even need to do anything special here? No, just add straight down. The y's will cancel. 6x equals 12, divide by 6, x equals 2. Now backtrack up to this last step. Plug x in for either one. How about the top one? That's 2. Come on, you're doing so well.
Well, is that the answer at top?
Oh, yeah, I forgot to cover it up. Turns out it will be. Yes, turns out the answer. You know what? I bet the question here was, is this a solution? Just like, remember yesterday, the first 1 or 2 we had was, is this a solution? Well, you know how to do that. So let's just do this one as an example. So you plug 2 in. I'll choose the top one. So that's 2 times 2. Please don't do that kind of stuff today. Equals 5. Subtract. Divide by -1. Oh, darn it. Hence that one. Plug x and y into any of these first three equations. First one looks good. 2 plus negative 1 plus z equals 4. That's 1 plus z equals 4. Subtract, and you get 3. The addition method is the method you're going to use most often in this section. That doesn't mean, however, that you cannot use substitution. You can. You can use substitution just like you did yesterday. However, you're probably going to want to save substitution. Just kidding. You're probably going to want to save substitution for ones like this. If you get one like this that has 2 variables in places, that's the best time to use substitution if you want to. Again, you still don't have to. No, z was 3. You plugged in negative 1 and 2, and for x and y, 2 plus negative 1 plus z. So it's 1 plus z equals 4. Subtract the 1, you get 3. And that's everything we're doing today. We're just going to do several examples until we're feeling pretty comfortable with it. Glad you're excited, Braden. All right. Pick one.
So does it matter what we go back and plug into as long as we get into
That's right. And you can check it by plugging it into all 3 and making sure it works. Which one? Number 5. What do you want to do? What letter do you want to get rid of? Now, when you're looking for a letter to get rid of, see if there's maybe just one positive in a row or just one negative in a row. That way, because here's what we're thinking. We could use this z to wipe out those 2, because since it's already negative, we wouldn't have to multiply through by any negative numbers. Not that that's a problem, but that's fair. It's a little headache. So I'm thinking use the bottom z, bounce it off the other 2 z's, and get rid of those. All right, so Hannah, since you picked this one, what do you want to multiply by to get rid of the top z? Sounds good. We're going to get rid of both of them. That way we have 2 equations without it. But yeah, we're just starting with that one. So, multiply that through. It's 2x plus 1x is 3x. I'm just, you know what? I won't skip steps. Multiplying by 2. Now we're going to add that to the top row. 2x plus 1x is 3x. 4y plus y is 5y. The z's cancel, which is what we wanted. 10 plus 11 is 21. Now what do you want to multiply by to get rid of the middle z? 3. Sounds good. If we multiply it by 3, what will that turn into? It'll be 3x plus 6y minus 3z equals 15. Now if we add that to the middle row, you get 4x plus 7y equals 29. Now we're right back to our comfort zone. 2 equations and 2 variables. Somebody want to suggest a method for this? Very good. And the bottom one by what? Good. That way it'll have negative 12, positive 12. I like it. That'll change the top one into negative 12x minus 20y equals negative 84. And the bottom one into 12x plus 21y equals 87. Add those up. Add those up. You get y equals 3. If you backtrack and plug it into one of these 2, I'll plug it into the bottom one. That'll give me 12x plus 63 equals 87. Subtract. Divide by 12. Does that give you x equals 2? Plug both of those into one of the originals. I'll plug it into the middle one right here, which would give me 4x. I'm sorry? Oh, yes we are. So don't use that equation. That would be very wrong. So which one do you want to use? Which one of the three originals? Top one. Good decision. So that'd be 2 plus 3 plus 2z equals 11. Subtract the 5. Divide by 2. So your ordered triple would be 2, 3, 3. These are actually the exact same as yesterday. The only difference is instead of representing line, they represent planes. Each one of these three variable systems of equations represent a plane. And again, there can be no solution, whether either parallel or two of them cross and one of them doesn't. There can be infinitely many solutions, meaning they're either on top of each other or like where does the plane of the ceiling meet the plane of this wall? Along that entire line. So there's infinitely many solutions. That's what that would represent. And then, of course, but most of the ones we're going to do, like this one, have one solution. 3 planes. Ceiling, wall, wall. They all meet at 1 point. And that's what most of these are going to be. Questions about any math that we did here? Okay. You can do substitution. And if you, yeah, go for it. Let's do the next one, substitution. There's obviously one on this page. It just looks uglier than the others. You want to do that one? Ooh, sounds fun. Although 15 is a classic case of one that would be perfect to do substitution. Or 13. You see how there's one or multiple equations with less than 3 variables? That's the best time to use substitution because that way you don't have to plug in as much. For instance, like let's say 15. 15. Let's solve for y. Y in the middle equation, I'm doing the middle one just so I can stay positive. 1 plus z. 1 plus z. Now if I plug that into the other two equations, what's that give me? That gives me, in the top one, I'm going to write it up here, x plus, but instead of y, that'd be 1 plus z equals negative 4. And if I plug that into the bottom one, that gives me 2x plus 1 plus z plus 3z. We're doing number 21. He wanted to try one using substitution method. So we solved for a variable in one of them, and we're plugging it into the other two. And as you can see, even though it looks uglier, Adam, we're still down to 2 letters. xz, xv. And it's just a 2 by 2 once you combine all your like terms. So yeah, substitution. But I personally would only do substitution if there was a 2 variable equation. Mm-hmm. Yeah, that's right. Well, let's see. What did you get for the other ones? Well, you have to do both of them. They have to go together. 2x, 1z, and 3z is 4z. 4z, 1z. No? Okay. Subtract the 1, you get negative 22. And now that you're here, it's just like yesterday. Just a 2 by 2. And I'm thinking maybe multiply the top one by negative 2 or something. Top one by negative 2. That'll give me negative 2x minus 2z equals 10. 2z equals negative 12, which would make z negative 6. Backtrack. Plug that into one of these. First one looks nice and handy. X minus 6 equals negative 5. Add the 6 is at 1. Now you've got 2 of them. This looks like a nice easy place to plug in to find y, because you only need one variable. So that'd be y equals 1 plus negative 6, so it'd be negative 5. So your order triple will be 1, negative 5, negative 6. Yes. Yes. This is not the sum. We multiplied this one by -2, and I just wrote it down. That way the x's will cancel, right? And giving me those cancel 2z equals -12. I just wrote it down. 17 looks bad, but really it's just nothing more than you have to do some combining of like terms before it's ready to roll. We can still do it, but so did that satisfy your craving for a substitution? All right. And you can do it with a 3-variable one, by all means. It's just a little bit more work because then you have to distribute 2 variables instead of just 1. Let's see, 17, and then I think we'll be done. We'll just set it up. I know you guys know how to work it once we get it set up. So that would be 6x plus 3y plus 5z equals -1. All we're doing right now is simplifying. Come on. All right, 2x I know it's too late for Christmas, but if anybody has a spare Moby laying around, never too late for me. This is a Moby. If anybody has another one of these. Or if you know a teacher that, what? No. If you know a teacher that's not using theirs, maybe you could hijack it or something. When I say hijack, I mean ask to borrow. Hey! That's a tragic shame. Stealing's never the right thing to do. There you go. That I can get behind. All right, the bottom one. Okay. Then we move all of that to the one side. So that'll give me x minus 9y plus 3z equals 4. So as you can see, 17 is going to set up just like the other one. It is. Good catch. And then when you get there, it's going to work just the same as the others. I would take the first one and get rid of the other two y's. That's just me. I don't care how you do it. There are so many different ways to work these problems that this is going to be the first section where, say someone comes in tomorrow and asks me to work this one, it might not look anything like yours, but as long as you get the same answer, that's all we care about. Just like yesterday, if you get a false statement, if everything cancels somewhere and you get like 0 equals 7, just like yesterday, no solution. Or if you get a true statement, like, what was the one you got yesterday? Was it like 12 equals 12 or something? That means you have infinitely many solutions. Same as yesterday. Alright, here you go. No. Yes, because that means you weren't watching my lessons.